Okay, well, thank you so much for inviting me here today. And I'm hoping to convey to you some of what we learned about Antarctica, but also its importance, and a little bit of a sort of personal story as well, all sort of tied in. Many of us don't really think about Antarctica because it's there sort of at the bottom of the globe and sort of far away from everyone, across this vast, hostile Southern Ocean. And so why do we even really care about it would be the question. And so this talk is, the title is Demystifying Antarctica. And what I want to tell you is what we've learned about this continent over the past century or so. We actually go back a bit further. And then the observations that we've collected, and then what's coming next as well. So I'm going to, this is the slide without the graphic. I wanted to actually take you back a little bit further, and we're going to go back to 1840. This is, on the right, is a newspaper article from the Hobart Gazette in 1840, and this was the first time in the media that Antarctica was reported. So they discovered the Antarctic continent in 1840. But what is very funny is what they wrote about it. The first sentence here that's highlighted: an interesting rather than important geographical discovery has this year been made in the southern Antarctic Ocean, an island or continent. And I'm not going to read the whole thing, but it's kind of delightful because honestly, what an understatement. I mean, it's definitely very important to us, and it's very important in the Earth climate system. And that was definitely a very interesting way of seeing it reported. Any of you who've been to Hobart, this is around the same time as the Kelly Steps were built. So this is the kind of thing that was going on in the world at this time. So this is a quote, and this sort of gives you tells you why I chose the title I chose. Where I did my PhD in Australia, Sir Douglas Mawson. He was an Antarctic explorer, and one of his famous quotes, which I've always loved because I think it still holds true today: we came to probe the Antarctic's mystery, to reduce this land in terms of science, but there is always the indefinable, which holds aloof, yet which rivets our souls. So what he's saying there is there's kind of always going to be something that we don't understand about Antarctica because it is such an incredible, vast continent. It changes on these very long time scales. Over here on the right is a photograph, a schematic from the IPCC, Intergovernmental Panel on Climate Change, showing how fast elements of the cryosphere change. And ice sheets are on a kind of centennial scale. In other words, they don't really respond very quickly to changes in climate because they're very thick. And we're seeing, we typically have thought about them as changing on these long time scales that really don't care to us as humans, right? Because who cares about anything beyond your own lifetime when you're a human? So sorry, that was a bit of a, but this is kind of we don't really think much beyond 100 years or so. But what we found, and I'm going to show you, is that actually, in fact, Antarctica is changing much faster than that. So here's a 100-year timeline going back to the sort of early 19th century and coming to the present day, showing the sorts of things that have happened in Antarctica over this 100-year period. So thinking about a century in the life of Antarctica. So this is the early days of the explorers. This is the Shackleton Endurance expedition. This is in at the end of the Second World War, sorry, and this is actually British Antarctic Survey unloading supplies somewhere near South Georgia. This is actually the first female science expedition, all-female science expedition to the Antarctic, and this is actually the year I was born, 1969. This is me on an ice shelf during my PhD in the mid-90s. And this is my former student with my current student in Antarctica in 2020. So this is kind of the evolution of, 100 years of Antarctica and tying my own story in it too. So let's go back a bit to the 1930s or so. And this is here, the first real map that we had. This is National Geographic map of the Antarctic continent. And you can see that, there's some parts of it that are actually mapped fairly well. Like this is actually fairly close to what we see now. But you can see there's a whole area over here on the west that's really murky. Like this is not at all well defined. You might have heard the phrase terra incognita, unknown land. associated with Antarctica, and that's because we really didn't know. It's so far from anything that we know and so remote, and it's been very difficult to get measurements from this continent without going there, and then that involves going across this hostile ocean, which is very tough to navigate. This here is the Antarctic Peninsula, and I'm going to talk more about this towards the end of the talk because I've just returned from this part of Antarctica. So it is the part that is close to South America. It's actually accessed from Punta Arenas, which is the bottom part, a very southern tip of Chile. And so we'll talk a little bit about what's happened on the Antarctic Peninsula. So this is showing you sort of ramping up of activity. This is following the Second World War and the US Navy, and there was also some British activity in the region, and there was a lot of sort of information collection. There was one airborne survey that went around the western loop of Antarctica and one around the eastern, and they collected and surveyed and started naming a lot of features in Antarctica during this time. It was called Operation High Jump, and it was definitely a really intense period of activity. They had some not so successful things with ships getting stuck in between ice, but for a lot of this is quite important in Antarctic history in terms of some of the names that we still use today have come from this time. This is another sort of media. It's kind of interesting to see how the media coverage of Antarctica has changed throughout the years. So this was how the Operation High Jump featured in a Hobart newspaper mapping Antarctica. And so what sort of started ramping up about 10 years after that was this thing called the International Geophysical Year. And during this time, geophysicists all around the world got together and made a lot of measurements about many, many things in the Earth system, not just Antarctica. So this is when a lot of intense activity started, monitoring all sorts of very important parameters about the planet and how they're changing. And so this was also a period of activity in Antarctica. It's actually roughly when the Antarctic Treaty was signed, and also it's when we started measuring carbon dioxide in the atmosphere at Mauna Loa, Hawaii, which was actually Professor Charles David Keeling of Scripps Institution of Oceanography, where I am. Well, not today. I'm at home, but that's where I work. This is actually a plaque from a building at Scripps. And this is the Keeling curve measuring how much humans are emitting carbon dioxide into the atmosphere and how that's gone up since 1958. So the point being, these sort of long-term records that started around the 1950s have actually told us a lot about the climate system and how it's changing. So I'm now going to show you a little bit about what we've learned about Antarctica since that time. Back to our timeline. Obviously, we've been very limited. We were very limited in the past by the technology. So most of the measurements were made by ground or by sea. So a lot of the mapping was done by ships, and some sort of leveling surveys on the ground and people going in literally boots on ground on foot. But around the time of after the Second World War, we had the airborne surveys that I just talked about. And then in the early 70s, there was the launch or the advent of a new era of collecting observations, and this is satellite remote sensing. Now, I'm very involved in that now. Like basically, I guess the time that I was born was sort of the beginning of the era of satellite data, and so by the time I got to school and then to college, this was when it was really ramping up in terms of a tool for collecting information about Antarctica. So these are the first images that ever came from the Antarctic ice sheet in the early 70s. So I was only 4 or something. And this is a Landsat image. It's literally just a photograph taken from space, but it's very high up, obviously, like 600-700 kilometers above the Earth, orbiting around, taking photographs. And this actually became the glacier system that I studied for my PhD. So this is ice flowing off this way and out towards the ocean, which wasn't captured. This is Pine Island Glacier, taken in 1973. And this is now a region that we know is changing very quickly and contributing a lot to the sea level rise, which I'll talk about. These are published by the British Antarctic Survey in the early 80s. So also in the 80s, this is when my story overlaps with Melissa's story, and I'm so grateful that she invited me to give this talk today, and and gave the wonderful introduction earlier. So yes, in 1979, my family moved to Altrincham. You all know what Altrincham is, so I didn't really need the map, but this has been used in other talks. And Altrincham Grammar School for Girls was where I met Melissa. I think it was around 1983. We might have that plus or minus a year uncertainty. And Melissa had actually just come from Sale Grammar, if I got it right. She was an incredibly enthusiastic, totally wonderful physics teacher. I hope I'm not embarrassing you, but you really did inject energy and just incredible fascination into me for the world of science and physics and how important it is. This is what I looked like around about that time. Yeah, I was definitely a bit of a wild teenager. I think my mum is on the line. She'll remember this, of course. Really all I cared about was Duran Duran at this point. So the fact that Melissa actually managed to like instigate this love and passion of science was truly brilliant, and definitely I am indebted to her for much of my career. She was definitely very pivotal in my career path. So another sort of pivotal career move for me was going to University College London, UCL, and I was incredibly fortunate there as well to overlap with Professor Chris Brackley and Seymour Laxton. And so they were actually mentors for me in my final year of undergrad, and I was taking maths and physics, and I was able to take a class with, do a project with them about mapping icebergs as they break off Antarctica using satellite imagery. So this really did start my passion for Antarctic science. So at this time in the 90s, there was this first report of the IPCC, this Intergovernmental Panel on Climate Change, and this report had just come out, and basically what it said was, you know, the ice sheets really were not even mentioned. Climate is changing. It looks like humans might be causing it, but really ice sheets are changing on these long time scales, and we don't really care about them. So this was the kind of thing that framed my going into my PhD was ice sheets. Yeah, they're important, but they're not really changing fast enough to worry about it, which was kind of interesting. Oh, this was my first paper with Seymour. In round about the same time in the 90s was when we had one of our first satellite mosaics of the Antarctic continent. And because Antarctica is so large, the only way to really get a true picture of it and map it, remember there's parts of Antarctica that we hadn't mapped before over in the west from that image I showed you from the 1930s. Now we have satellites in up orbiting, and they can take images and we can put them all together in a mosaic, literally just like a collage of all these images. And now Antarctica jumps out at us, and we can see it, and we can see things like ice flow. We can actually see the ice flowing if you look very carefully, and features in here that made glaciologists sort of look at it and go, wow, okay.